So today let's talk about the discriminant. So can somebody tell me one way that we have used the quadratic equation so far? We've used 3 distinctive ways. Excellent, Armando. We have factored. That's part of factoring. What does factoring look like? What did we use to factor? We used a box method, and sometimes we used an X along with the box method, and we kind of factored it like this. All right, what were we finding when we were factoring? Roots. Excellent. We were finding roots. Can you think of another way that we found roots? I don't know, 2 months ago? We've been doing this for a while. There's 3 ways that we had found roots so far in this class. Excellent. We graphed. That's how we started this off. We started this whole chapter off by graphing, correct? So when we graphed, we actually used an XY table, and we found ourselves a parabola, and sometimes it had roots. It either had 1 root, 2 roots, or no root. Okay, so this is an example of a parabola that has 2 roots. There's a 3rd way that we've used our quadratic equation. We haven't done the quadratic formula yet. What do we just do? You're on fire today. Completing the square. So when we completed the square, what we were doing was taking that middle term b, dividing it by 2, and then squaring it, right? To give us a perfect square trinomial is what we were trying to find, and then solving. So why do we need multiple methods like this? Can somebody tell me? Why do it all these different ways? Elton. Okay. Yeah, that's acceptable. So if you don't know how to do it one way, all right. I can think of a more direct way. Yes, Andrew. Depending on how the equation's set up. Why? Exactly. If you can't factor an equation, you can't use the box. Then what would you use? Okay, but graphing, sometimes it's not a very exact answer. But completing the square is easy if you have something like x squared plus 6x. You just take 6, divide it by 2, and square it. What could be an equation where it wouldn't be so much fun? Negative doesn't matter. I could make it negative 6. You're almost there. You're almost there. You. How does it turn into a fraction? Think of another number other than 6. 6 works real well. What would be a number? There you go, right there. So what are you talking about when I say odd numbers? When it's an odd number and you try and divide it by 2, it's not going to simplify, right? And then you're completing a square with a fraction, and that's no fun. So we have our final method that we're going to be talking about today and tomorrow. The quadratic formula. Right? So when we can't find another way to do it, or it doesn't look easy enough for us, we can always use the quadratic formula. Some of the other methods don't work all the time. The quadratic formula works each and every time. Okay? But why do we not go straight to the quadratic formula? Because it's long. Who wants to use this long formula each and every time when sometimes you could just factor it like that? Right? Okay. So what we're going to do today is we're not going to do the whole quadratic formula. We're going to do a piece of the quadratic formula called the discriminant. But before we do that, I'm going to work through each one of these quadratic formulas so you can see how the discriminant affects the quadratic formula. The discriminant is actually only this piece of the quadratic formula. It's what's underneath the radical sign. And that discriminant will tell me whether or not I have one root, two roots, or no roots, right from before I do any of the other work. All right, so let's look at an example of this. So tell me what A is, what B, and what C. So I'm going to fill this in. B goes here. See, I've got the quadratic formula down here in the corners for your reference. B is 1, so I'm going to put a 1 in here and here. A is 2, I'm going to put it 2 in here and here. And C is 3. So when I solve for this, I get -1 plus or minus the square root of 1 minus, let's see, 24? All over 4. Well, when I continue to simplify this, I'm going to get -23. Can you solve for -23? No, actually, that's an irrational number, right? So, since this doesn't give me any type of solution, I can already say, just by the fact that there's a negative underneath this radical sign, that there are no roots to this equation. So if there are no roots to this equation, tell me which one of these graphs that this matches. Why? It never touches the x-axis. Perfect. All right, let's do this one. A equals 1. B equals 6. C equals 9. So I'm going to fill in my B. I'm going to fill in my A. I'm going to fill in my C. Simplify, I get -6 plus or minus, and we'll do this slower tomorrow. Okay, I'm just trying to show you what I'm doing to find this discriminant. 6 squared is 36. -4 times 1 times 9 is -36. What are you seeing with this one? They cancel each other, or you end up having a 0 underneath the radical sign. Well, if I have a 0, am I adding anything to -6? So I simply have -6 divided by 2, which is -3, which is 1 root. Therefore, if you get a 0 underneath the radical sign, you will always only have 1 root. So which one of these is that? The first one. Why? It only touches the x-axis 1. Those are good. All right. A equals 1. B equals. C equals. Fill this in here, and I have a -5, and a -5, and a 1, and a 1, and a 2. I get 5 plus or minus the square root of 17. 25 minus 8 is 17. All over 2. I can't simplify 17, so this is going to end up being 5 plus the square root of 17 over 2, and my other root would be 5 minus the square root of 17 over 2. Therefore, when I have a positive number underneath the radical sign, I have 2 roots. Therefore, this would be the correct one. So this is the third one. This is the first, second, third. All right, so let's sum this up and talk about it. So if I have a square root, because this part is the discriminant right here. I just like to put the square root sign over it because it kind of reminds you of what's happening underneath the square root. So how could I fill this in? The blank determines how many blanks. The discriminant determines how many roots I have. Good job, guys. So, if I have no roots, that means I have what underneath the radical sign? Good. Irrational or negative number. One root means I have what? 0. 2 roots means I have a positive number. You guys are ready. All right, let me pass off the homework. Okay, so in order to do this one, first we need to move that -1 to the other side so we can put this into a standard equation. So when I move the -1 over, I have r squared plus 2r plus 1 equals 0. So let's substitute our values in and find out what we get. If b is 2, and a is 1, and c is 1, we get 4 minus 4 equals 0. Pretend like that's underneath the square root sign. There are 1 solution. So what do I do with this one? Bring it over. So -n squared plus 2n minus 5 equals 0. A is -1, B is 2, C is -5. So if B is 2, -1, -5, 4, -4 times -1 is +4, but +4 times -5 is -20, which makes -16. Take the square root, and there are no solutions. None, no roots. You could write none. Or 0. Okay, and that's it for today.